Okay, good morning, children. Today we are doing colligative properties. It's in solution chapter. First of all, which properties are colligative properties? Number one, relative lowering of vapor pressure is a colligative property. Number two, elevation in boiling point is a colligative property. Number three, depression in freezing point is a colligative property. Number four, osmotic pressure is a colligative property. These properties, basically for dilute solution does not depend on nature of solute particles. They do not depend on nature of solute particles, but depends on relative number of solute particles. So properties of dilute solution which does not depend on nature of solute particles but depend on relative number of solute particles are called colligative properties. Now let me write down the symbol. Osmotic pressure is pi, depression freezing point is delta Tf, elevation in boiling point is delta Tb, relative lowering of vapor pressure is we denote it by say delta Pa by Pa naught. This is a symbol. So basically, in exam, numericals on these comes in exam. So let me quickly write down the relationship here. Relative lowering of vapor pressure, that is Pa by Pa naught. Okay, this is equal to mole fraction of solute. Relative lowering vapor pressure is equal to mole fraction of solute. This is also a statement of Raoult's law. You can say this statement if you are asked what is Raoult's law. Then elevation in boiling point relation is delta Tb is equal to Kbm, where Kb is called molar ebullioscopic constant or molar elevation constant. This Kb has different value for different solvent, and M stands for molality of the solution. Molality. Similarly, depression in freezing point delta Tf is equal to Kfm. This is Kf is molar cryoscopic constant, and once again here molality of the solution, and osmotic pressure pi is equal to your CRT, where C is the molarity of the solution, T is the temperature in Kelvin, and R is the universal gas constant. So basically, using this relation, we can calculate, do the numericals. First, let me tell you the importance of colligative property. The importance of colligative property lies in experimental determination of molecular mass of solute. That means MB. This colligative property are important, so that we can find out MB value, molecular mass of solute. That's why these colligative properties are very important. Okay, so first of all, let us do one question here on this relative lowering vapor pressure. So the question is like this. Okay, so here is a question you see. Vapor pressure of water at 293 Kelvin. It is 17.51 millimeter. Lowering of vapor pressure of sugar solution is 0.0614 millimeter. And we have to find relative lowering of vapor pressure. That means we have to find this quantity. We have to find vapor pressure of solution. Vapor pressure of solution means we have to find PA. We have to find mole fraction of water, that is chi A, mole fraction of water. So these are the things we have to find. Delta PA by PA naught. These are the things we have to find. And what are the things given? Let me write down. What are the things given? What is this? This is lowering. That means this value that is given, it is delta PA is given. So delta PA is 0.0614 and this value that is given, it is of PA naught. PA naught value is given 17.51 millimeter. So these are the things that are given. So first of all, so the first quantity, it will be straightforward. It is we have to find PA by PA naught. So delta PA by PA naught. So it is 0.0614 by 17.51. This will be the answer. And if you simplify this, then answer you will get is 0.0035. 0.0035. So this you are getting. The first answer. And the second one is vapor pressure of the solution. Vapor pressure of solution, since we have to find PA we have to find. So let me write it down from here. This delta PA is PA naught minus PA by PA naught. And chi B, this is mole fraction we have already found. This is mole fraction of solute. So 0.0035. So now let us put the values here. PA naught is 0.0614 by minus PA by 0.0614 equal to 0.0035. So you see, children, now there is only one unknown here, so you can easily find PA. And I'm just telling the answer of PA here. PA that will come out will be 17.44. PA that will come out is 17.44 millimeter. That will be the value of PA that you will get after solving this. Okay, and the third part, since we are asked to find mole fraction of water, since you know this is mole fraction of solute, this is chi b, and chi a no will be 1 minus chi b, so 1 minus 0.0035, and from here you can easily get the answer, and that answer will be 0.9964. 0.9964. So this is done. Now one thing I'm going to say you here is since the application of colligative property is in determination of molar mass of solute. Okay, so let me get the expression for molar mass of solute. Expression for molar mass of solute. So this is equal to NB by Na plus Nb, and now we do an approximation. Now we often do approximation here that we write very nearly equal to Nb by Na. That means we ignore this part. And approximately we write it like this. And from here we get M, your mass in gram by molar mass. Here also mass in gram of solvent by molar mass. And we get this Wb by Mb into Ma by Wa. So this we get, and expression for Mb that we get is Wb into Ma by delta Pa by Pa naught into Wa. So this is the working formula that we get for determination of molecular mass of solute from relative lowering of vapor pressure. You see, all the quantities in the right hand side are known to us. This is the mass of solute we know because we have prepared the solution. Molecular mass of solvent is known to us. Wa is also known to us. What is the mass of solvent that we have used? And this is obtained directly from an apparatus. So we get Mb value. But one thing, we may not do this approximation. And we can get correct value. Here we won't get so correct value without approximating. We do approximation for making the calculation easier. Now I am showing you here without approximation how can we get correct value of Mb. So without approximation, how can we get correct value of Mb? That I would like to show here. Okay, so it is like this. So straight away I am writing this equation: delta Pa by Pa naught is equal to Nb by Na plus Nb. Now let us make it upside down. So it will be Pa naught by delta Pa is equal to Na plus Nb by Nb. or PA naught by delta PA will be NA by NB plus NB by NB. So it will be PA naught by delta PA is equal to 1 plus NA by NB plus 1. So now this one we bring it this side. So we from here we get NA by NB equal to PA naught by delta PA minus 1, and here we get this PA naught by this delta PA is PA naught minus PA, this delta PA minus 1. And if I take LCM and calculate, so it will be PA naught minus, and this one will be minus PA naught plus PA. And then from here this PA naught cancels, so we get NA by NB is equal to PA by PA naught minus PA. Okay, and from here we can write NB by NA is equal to PA naught minus PA by PA. So just have made upside down. Okay, upside down. So now you see, since we know NB by NA is this expression, so let me write down this directly. For NB by NA is WB by MB into MA by WA is equal to this PA naught minus PA by PA. So you see, using this expression we can easily get MB, and we have not done any approximation. We haven't done any approximation. So you see, if molecular mass expression value you are asked, you can use this. In this way you can do this, and you will get correct value, and that ambiguity, whether you will do approximation or whether you will not do approximation, that also gets removed here. Okay children, so in today's class we will be doing this much today, and I will be taking up the other colligative properties in the next videos. Okay, till then, have a good day.